This week on the show, we have the strange birth and long life of Unix for you, FreeBSD jails covering a single public IP, EuroBSDcon 2018 talks and schedule is available, OpenBSD on a G4 iBook, a PAM template user example for you, ZFS file server setup, and reflections on 1 year of using OpenBSD in this week's episode of BSD Now. BSD Now, episode 259, Long Live Unix. Recorded for the 15th of August, because we were in Cambridge that time, 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Yeah, that's our episode where we are not actually here, but you have an episode to watch while we have fun in Cambridge. And before we get into our headlines this week, we start to raffle out our winner, or the one winner, for the Mojix Power Bagel that we have raffled off since episode 256. Remember our little contest there? And people have been sending us answers. Mostly were right. So it's about the numbers that were there in the 4 December episodes. We had people that were sending just one of them. And but a couple of people sent us their replies, which were correct, and we listed them here. And Alan will now play Lady Luck, or at least the random number generator would do that. And Alan just execute.
So we had 15 people who bothered to email in correct answers. And the winner is number 12, Eddie.
Eddie. Okay, so I will contact Eddie offline and make sure that this little item gets into Eddie's hands. It might take a while because shipping around the world sometimes takes longer than expected, wherever Eddie may be in relation to the Power Bagel. But other than that, congratulations. You are winner of episode 256 Gimmick, the Power Bagel. And you have 4 friends to connect you with this thing, which makes it even more awesome to have.
Yes. And all of you who procrastinated and didn't write in an answer, well, that's what you get. Nothing.
Yeah. Contest over. Better luck next time. Maybe we'll do something in the future if there's another lucky episode number coming up, or whenever we feel like it. Okay. Now that's off the track here. Let's head to the headlines, which has the strange birth and long life of Unix in this.
Yes. So they say when one door closes on you, another opens. People generally offer this bit of wisdom just to lend some solace after some kind of misfortune. But sometimes it's actually true. It certainly was for Ken Thompson and the late Dennis Ritchie, 2 of the giants of 20th century information technology, when they created the Unix operating system, now considered one of the most inspiring and influential pieces of software ever written. A door had slammed shut for Thompson and Ritchie back in March of 1969, when their employer, the American Telephone and Telegraph Company, now called AT&T, withdrew from a collaborative project with the Massachusetts Institute of Technology, the University MIT, and General Electric to create an interactive time-sharing system called Multics, which stood for Multiplex Information and Computing Service. Time-sharing was a technology that let multiple people use a single computer simultaneously. Had been invented only a decade earlier. Multics was to combine that time-sharing concept with other technological advances of the era, allowing users to phone into a computer from a remote terminal and use it to read email, edit documents, run calculations, and things like that. It was to be a great leap forward in the way computers were mostly used back then, where people tediously prepared and submitted batch jobs on punch cards to be run and then to get the output.
This would make the good old days.
Interactive.
Oh, yeah, very much so.
So over the span of 5 years, AT&T invested millions of dollars in the Multics project, including purchasing a GE 645 mainframe computer and dedicating the effort of many of its top researchers at the company's renowned Bell Laboratories, including Thomas and Ritchie, Joseph Osana, Stuart Feldman, Douglas McElroy, and the late Robert Morris. But the new system was too ambitious and fell troublingly behind schedule. In the end, AT&T's corporate leaders decided to pull the plug. After AT&T's departure from the Multics project, the managers at Bell Labs, the office in Murray Hill, New Jersey, where most of this happened, became reluctant to allow any further work on computer operating systems, leaving some researchers there very frustrated. That's what they were here for. Although Multics hadn't yet met many of its objectives, it had, as Ritchie later recalled, provided them with a convenient interactive computing service, a good environment in which to do programming, and a system around which a fellowship could form. Suddenly, that was gone. So with heavy hearts, the researchers returned to using their old batch system. At such an inauspicious moment, the management's dead set against the idea, it surely would have seemed foolhardy to continue designing a computer operating system. But that's exactly what Thomas, Ritchie, and many other Bell colleagues did. Now, some 40 years later, we should be thankful that these programmers ignored their bosses and continued their labor of love, which gave the world Unix, one of the greatest computer operating systems of all time. Mm-hmm. The Rogue project began in earnest when Thompson, Ritchie, and the third Bell Labs colleague, Rudd Kennedy, began to sketch out on paper the design for a file system. Thompson then wrote the basics of a new operating system for the lab's GE645 mainframe. But with the Multics project ended, so too had the need for that GE645. Thompson realized that any further programming he did was likely to go nowhere, so he stopped the effort. Thompson had passed some of his time after the demise of Multics writing a computer game called Space Travel, which simulated all the major bodies in the solar system along with a spaceship that could fly around between them. Written for the GE645, Space Travel was clunky to play and expensive, roughly $75 a game for the CPU time it took to play. Hunting around, Thompson came across a dusty old PDP-7, a mini-computer built by the Digital Electronic Corporation, that some of his Bell Labs colleagues had purchased earlier for a circuit analysis project. So Thompson rewrote his space travel game to run on that. And with this little programming exercise, a second door cracked ajar. It was to swing wide open in the summer of 1969 when Thompson's wife, Bonnie, spent a month visiting his parents to show off their newborn son. Thompson took advantage of his temporary bachelor existence to write a good chunk of what would become the Unix operating system for that discarded PDP-7. The name Unix stems from an old joke one of Thompson's colleagues made. Because the new operating system supported only one user, Thompson, he saw it as the emasculated version of Multics and dubbed it the Unmultiplexed Information and Computing Service, or Unix, U-N-I-C-S. The name later morphed into Unix with an X. So initially, Thompson used the GE645 to compose and compile the software, which he then downloaded to the PDP-7. But he soon weaned himself off of the mainframe, and in the end of 1969, he was able to write an operating system on the PDP-7 itself. That was a step in the right direction. But Thompson and others who were helping him knew that the PDP-7, which was already obsolete, would not be able to sustain a skunkworks like this for long. They also knew that the lab's management wasn't about to allow any more research on operating systems. So Thompson and Ritchie got creative. They formulated a proposal for the boss to buy one of DEC's new mini-computers, the PDP-11, but couched the request in especially palatable terms. They said they were aiming to create tools for editing and formatting text, and that you might call a word processing system today. The fact that they would also have to write an operating system for the machine to support the editor and text formatter was almost a footnote. Management took the bait, and an order for PDP-11 was placed in May of 1970. The machine itself arrived soon after, although the disk drives for it took more than 6 months to actually appear. During that interim, Thompson, Ritchie, and others continued to develop Unix on the PDP-7. After the PDP-11's disks were finally installed, the researchers moved their increasingly complex operating system over to the new machine. Next, they brought over the ROF text formatter written by Joseph Osana and derived from the runoff program, which had been used in an earlier time-sharing system. Unix was put in its first real-world test with Bell Labs when 3 typists from AT&T's patent department began using it to write, edit, and format patent applications. It was an instant hit. The patent department adopted the system wholeheartedly, which gave the researchers enough credibility to convince management to purchase another machine, a newer and even more powerful PDP-11, a newer model, although their stealth work on Unix could continue.
Yep.
During its early days, Unix evolved constantly, so the idea of issuing named versions or releases seemed inappropriate. But the researchers did issue new editions of the programmer's manual periodically, and the early Unix systems were named after each of the editions of the manual.
Mm-hmm. Okay.
The first edition of the manual was completed in November of 1971. So what did the first edition of Unix offer that made it so great? For one thing, the system provided a hierarchical file system, which allowed something we now take for granted, having files that can be placed in directories, rather than every file just being in the root of the file system.
Yeah, it's a Unix system.
Each file could contain no more than 64 kilobytes of data, though, and its name could be no more than 6 characters long. These restrictions seem awkwardly limiting now, but at the time, they seemed entirely adequate. If you're writing just pure text, 64 kilobytes is quite a bit of text. So
yeah, you can go a while
into
with that.
chapters and you're fine. So, although Unix was essentially created for word processing, the only editor available in 1971 was the line-oriented ed.
Woo!
There's a whole book on that if you're interested.
Yeah, it's just great.
Today, ed is still the only editor guaranteed to be present on all Unix systems, apart from the text processing and general system applications. The first edition of Unix included games such as blackjack, chess, and tic-tac-toe. For the system administrator, there were tools to dump and restore disk images to magnetic tape, to read and write paper tapes, and to create, check, mount, and unmount those removable disk packs. Which, not like a floppy disk or a USB stick today, the disk packs were huge. Most important, the system offered an interactive environment that by this time allowed time sharing, so several people could use a single machine all at once. Various programming languages were available, including BASIC, Fortran, and scripting for the Unix command line, assembly language, and B. The last of these, a descendant of BCPL, the Basic Combined Programming Language, ultimately evolved into its immensely popular C programming language, which Rishi created while also working on Unix. Again, part of the reason was, as they kept moving between different hardware, they wanted to be able to use the same code.
Makes sense.
So the first edition of Unix let programmers call 34 different low-level routines built into the operating system. I think even today, the number's only 200-ish.
Yeah, they haven't grown out of proportions.
It's a testament to the system's enduring nature that nearly all of these system calls are still available and heavily used on modern Unix and Linux systems, even 4 decades later. For its time, first edition Unix provided a remarkably powerful environment for software development. Yet it contained just 4,200 lines of code at its heart and occupied a measly 16 kilobytes of main memory when you ran it.
Oh, yeah.
I do believe we have more than 4,200 lines of code for some really trivial things nowadays.
Yeah, unfortunately, some bloat has happened over the years. Yeah.
I think I've written that much ZFS code myself. Anyway, Unix's great influence can be traced in part to its elegant design, simplicity, portability, and the serendipitous timing. But perhaps even more important was the devoted user community that soon grew around it. Going back to some of the original ideas with Multics, it was something we could build this fellowship around. And that came about only by an accident of its unique history. The story goes like this. For years, Unix remained nothing more than a Bell Labs research project, but in 1973, its authors felt the system was mature enough for them to present a paper on it at a design and implementation symposium at the Association of Computer Machinery. This paper was published in 1974 in the Communications of the ACM. Its appearance brought a flurry of requests for copies of this magical software. That put AT&T in a bind. In 1956, AT&T had agreed to a U.S. government consent decree that prevented the company from selling products not directly related to telephones and telecommunications, in return for its legal monopoly status in running the country's long-distance phone service. So Unix could not be sold as a product. Instead, AT&T released a Unix source code under a license to allow anyone who asked, charging only a nominal fee. The critical wrinkle here was that the consent decree prevented AT&T from supporting Unix. Indeed, for many years, Bell Labs researchers proudly displayed their Unix policy at conferences with a slide that read, "No advertising, no support, no bug fixes, payment in advance."
Oh, great. That wouldn't work nowadays.
Well, isn't that exactly what we do with FreeBSD?
Yeah, but not that explicit. I mean,
well,
as a selling
I guess
point.
we do offer some bug fixes.
Yeah. Oh, yeah, sure. From time to time.
So, with no other channels of support available to them, early Unix adopters banded together to provide mutual assistance, forming a loose network of user groups all over the world. They had the source code, which helped a lot. And they didn't view Unix as some standard software product because nobody seemed to be looking after it. So these early Unix users themselves set about fixing bugs, writing new tools, and generally improving the system to better suit their needs. The Unix user group acted as a clearinghouse for the exchange of Unix software in the United States. People could send in magnetic tapes with new software fixes for the system and get back tapes with software and fixes from other members. In Australia, the University of New South Wales and the University of Sydney produced a more robust version of Unix, the Australian Unix Share Accounting Method, which could cope with large numbers of concurrent users and offered even better performance. So by the mid-1970s, the environment of sharing had sprung up around Unix resembled the open source movement so prevalent today. Users far and wide were enthusiastically enhancing the system, and many of their improvements were being fed back to Bell Labs for incorporation in a future version. But as Unix became more popular, AT&T's lawyers began looking harder at the various licensees and what they were doing with the systems. One person in particular who caught their eye was John Lyons, a computer scientist then teaching at the University of New South Wales in Australia. In 1977, he published what was probably the most famous computing book at the time, a commentary on the Unix operating system, which contained a complete annotated listing of the source code for Unix with notes about it and so on. Unix's license condition allowed for the exchange of source code, and initially Lyons' book was sold to licensees. But in 1979, AT&T's lawyers had clamped down on the book's distribution and use in academic classes. The anti-authoritarian Unix community reacted as you might expect, and started photocopying copies of the book and spreading them around. Many of us have nearly unreadable nth generation photocopies of the original book.
Yeah, the copy of the
most
copy
people
of the
had
copy.
Very degraded copies.
Fax me your copy so I can copy it a couple of times more. Yeah, that's
give it to
probably
some
how it
friends,
goes.
and then they'll copy it for their friends, and eventually it'll just be a grainy thing nobody can read.
What's this? Yeah.
This end run around AT&T's lawyers indeed became the norm, even at Bell Labs. For example, between the releases of the 6th edition of Unix in 1975 and the 7th edition in 1979, Thompson collected dozens of important bug fixes to the system, coming both from within and without the Bell Labs. He wanted these to filter out to the existing Unix user base, but the company's lawyer felt that it would constitute a form of support and balked at doing a release. Nevertheless, those bug fixes soon became widely distributed through unofficial channels. For instance, Lou Katz, the founding president of Unix, received a phone call one day telling him that if he went down to a certain spot on Mountain Avenue, where Bell Labs was then located, at 2 p.m., he would find something of interest. Sure enough, Katz found a magnetic tape with the bug fixes, and then he started spreading it to users.
This sounds like a
bad
spy story.
Movie.
Yeah. Oh, wow.
So by the end of the 1970s, Unix, which had started a decade earlier as a reaction against the loss of the comfortable programming environment of Multics, was growing like a weed through academic and IT industry. Unix would flower in the early 1980s before reaching the height of its popularity in the early 90s. For many reasons, Unix has since given way to other commercial and non-commercial systems, but its legacy, that of an elegant, well-designed, and comfortable environment for software development, lives on. In recognition of their accomplishments, Thompson and Ritchie were given the Japan Prize earlier this year, when I'm not sure which year this article was written, adding to a collection of honors that include the United States National Medal of Technology and Innovation and the Association of Computing Machinery's Turing Award. Many others, often very personal, tributes to Ritchie and his enormous influence on computing were widely shared after his death just a few years ago. Unix was indeed one of the most influential operating systems ever invented. Its direct descendants, now numbering the hundreds, on one side of the family tree, there are the various versions of Unix proper, which began to be commercialized in the 1980s after the Bell Systems monopoly was broken up, freeing AT&T from the stipulations of that 1956 consent decree that stopped them from selling other products and services. On the other side are various Unix-like operating systems derived from the versions of Unix developed at the University of California at Berkeley, including the one Apple uses today in its computers, OS X. I say Unix-like because the developers of BSD, the Berkeley software distribution, Unix, on which these systems are based, worked hard to remove all of the original AT&T code so that their software and its descendants would be freely distributable. Yep. The effectiveness of these efforts were, however, called into question when AT&T's subsidiary, Unix Systems Laboratories, filed suit against the Berkeley Software Design and the Regents of the University of California in 1992 over intellectual property rights for the software. The university, in turn, filed a counterclaim against AT&T for breach of the license it provided AT&T for the use of code developed at Berkeley. The ensuing legal quagmire slowed the development of free Unix-like clones, including 386BSD, which was designed for the Intel 386 CPU. And this is the reason why Linux ended up being invented and why FreeBSD kind of missed out on being the de facto operating system for probably almost everything, if it hadn't been for this one pesky lawsuit.
But we got out of it.
Yeah, so had this operating system been available at the time, Linux Torvald says he probably wouldn't have bothered creating Linux, an open source Unix-like operating system he developed from scratch for his PC in the early 90s. Linux has carried the Unix baton forward into the 21st century, powering a wide range of digital gadgets, including wireless routers, televisions, so on. You know, FreeBSD is still here.
Yeah, we're not dead yet.
And we're running in televisions and routers and washing machines.
We're there, yeah.
And, you know, Android smartphones contain a bunch of BSD too. Anyway, although AT&T quickly settled its legal dispute with BSDI and the University of California, legal wranglings over intellectual property claims to various parts of Unix and Linux have continued over the years, often involving Byzantine corporate relations. By 2004, no fewer than 5 major lawsuits have been filed. And even just a couple of years ago in August, a company called TSG, which had bought up part of SCO Group, lost a bid in court to claim ownership of the Unix copyright that Novell had acquired when it purchased the Unix Systems Laboratories from AT&T in 1993.
That mess.
As a programmer and Unix historian, I can't help but find all this legal sparring a bit sad. From the very start, the authors and users of Unix worked as best they could to build and share, even if it meant defying authority. That outpouring of selflessness stands in sharp contrast to the greed that has driven the subsequent legal battles over the ownership of Unix.
Here.
The world of computer hardware and software moves forward startlingly fast. For IT professionals, the rapid pace of change is typically a wonderful thing, but it makes us susceptible to the loss of our own history, including the important lessons from the past. To address this issue in a small way, in 1995, I started a mailing list of old-time Unix aficionados. This effort morphed into the Unix Heritage Society. Our goal is not only to save the history of Unix, but also to collect and curate those old systems and, where possible, bring them back to life. With help from many talented members of this society, I was able to restore much of an old Unix software to working order, including Ritchie's first C compiler from 1972 and the first Unix system to be written in C dating from 1973.
Oh, wow.
One holy grail that eluded us for a long time was the first edition of Unix in any form, electronic or otherwise. Then, in 2006, Al Kassow from the Computer History Museum in Mountain View unearthed a printed study of Unix dated from 1972, which not only covered the internal workings of Unix, but also included a complete assembly listing of the kernel, the main component of the operating system. This was an amazing find, like discovering the old Ford Model T collecting dust in the corner of a barn. But we didn't just want to admire the chrome work from afar. We wanted to see if it would run again. Mm-hmm. So, in 2008, Tim Newsom, an independent programmer in Hawaii, and I assembled a team of like-minded Unix enthusiasts and set out to bring this ancient system back from the dead. The work was technically arduous and often frustrating, but in the end, we had a copy of the first edition of Unix running on an emulated PDP-11/20. We sent out messages announcing our success to all those who thought it would be interesting. Thompson, always succinct, simply replied, "Amazing." Full stop.
Yeah.
Indeed, his brainchild was amazing, and I've been happy to do what I can to make it, and the story behind it, better known.
Oh, yeah. And the rest is history. And it's continuing. I mean, in 20 years, maybe someone else will report the missing bits that we are now writing. And yeah, it's part of the Unix story.
It's another thing where we're being as careful as we can consciously be with FreeBSD to make sure we keep as much of the old stuff around as we can.
Yeah, the Unix torch and, the old ideas and the concepts of Unix and its underpinnings.
A thing that's come up recently is in commit messages, we often reference external things. I think it originally came up because somebody was linking to a GitHub thing that contained more context, like I think it was the PR or something.
Yeah.
And so if it's the FreeBSD bug database, we have basically everything's in Bugzilla. We imported the old NATs into Bugzilla. So I think every bug that's ever been filed against the FreeBSD project is in that database. But when we reference things like GitHub, if 20 years from now GitHub is gone, which entirely possible, those links won't work anymore.
Yeah, and that's that
and
history.
It's like, how do we drive a version of archive.org or something that just crawls any links in commit messages and make sure we archive a copy of that context?
Yeah, that's a major undertaking.
We have the mailing list archives, and we have the bug database, and we have our reviews database, but we need to maybe look at trying to archive external things.
Yeah, and then the history is preserved. But it's difficult because the net is spreading and...
more of these software archaeologists and anthropologists.
Yeah, digging into the histories of the early days.
Helping preserve the history of all this Unix stuff.
Yeah, great article, for the beginning of BSD and Unix.
So it probably won't help you run first edition Unix, but if you do want to run modern Unix on a machine, you might want that machine to be in the cloud and have fast internet. So head over to digitalocean.com and spin up a droplet. It takes less than a minute, and you can get a machine with 1 gigabyte of memory. Remember, Unix first edition only took 16 kilobytes of memory.
That's a lot now, yeah.
A modern vCPU, 25 gigabytes of SSD disk, which is so much faster than the disk back then that you can't even measure it, and includes 1 terabyte of internet transfer on the gigabit connection for the VM. All
Yeah,
that
or
for just $5. Or
yeah,
actually, 0.7 cents per month.
very low entry to start, and you always wanted maybe to build a little cluster with multiple machines communicating among each other. That's also possible by spinning up multiple of those and connecting them. You don't
And
even
because of the hourly pricing, you don't even need to spend $5 in each one. If you're only going to play with it for the weekend, that's 0.7 cents times 4 instances times 6 hours or whatever. It adds up to not very much.
and you can start right away because you don't have to spend much time installing, because with the pre-built apps, you can basically have a pre-installed version there, no installing, no much configuration going on, and you can just connect them together and then they will work their little way. Or do a global availability thing over multiple regions where you can select which data center these run on, and then you have a globally distributed networky thing, whatever it might be in DigitalOcean's cloud.
Yep. And remember, if you go to do.co/BSD now, you can get a $100 credit for your account. That deal is not going to last. You need to hurry up and do that soon. It only lasts 60 days. Once you sign up, you get the money for 60 days, but you won't be able to sign up for very much longer. So you need to hurry up and take advantage of that and try it out for free before you miss your chance.
Yeah. With a new account, you can charge that up, and $100 goes a long way in DigitalOcean.
Yeah. If instances are $5 or $10 or $15 for 3 gigs of RAM, then even over 60 days, you'd have to spin up, 2 machines. You need like 6 gigs of RAM for 2 months for free. Come on. So
how much can you do?
If you already have an account, use the coupon code FreeBSD now, and you'll get a $10 credit that doesn't expire.
Oh yeah, that's also a worthwhile start. So you can try out DigitalOcean the way it works, and if you like it, then keep your droplets. It's fine.
So hurry up and do that before time runs out.
Yep.
Speaking of that, if you happen to have a DigitalOcean droplet, it only has one IP address. If you want to run a bunch of jails, how do you do that?
Yeah, that's kind of an interesting question, but this article here, or this little tutorial, actually answers that, because this says FreeBSD jails with a single public IP address. So this starts with jails in FreeBSD provide a simple yet flexible way to set up a proper server layout. In the most setups, the actual server only acts as the host system for the jails, while the applications themselves run within those independent containers. Traditionally, every jail has its own IP address for the user to be able to address the individual services running in them. But if you're still using IPv4, this might get you in trouble, as the most hosters don't offer more than a single public IP address per server. So first, you create the internal networking. In this case, network address, translation-based, or NAT for short, is a short and good way to expose services in different jails using the same IP address. So first, let's create an internal network at 192.186.0.0/24. You could generally use any private IP address they write, as specified in RFC 1918. But here's an overview of private networking on Wikipedia if you want to read up on that. So using PF, FreeBSD's firewall, or at least one of them, we will map requests on different ports on the same public IP address to our individual jails, as well as provide network access to the jails themselves. So first, let's check what network interfaces we have, actually. In this case, there's an EM0, which provides connectivity to the internet, and LO0, which is the local loopback device. So this is the output here. And so for our internal network, we create a clone loopback device called LO1. Therefore, we need to customize the rc.conf file in etc, adding the following lines. So cloned interfaces equals LO1, and IPv4 addresses for LO1 in 192.168.0.1-9/29. So this defines a /29 network offering IP addresses for a maximum of 6 jails. And this is the IP calculator, so you can see how the subnet mask matches to that, and the bits with the wildcards and all that. now we need to restart the network, of course, to actually make those changes set in the system. They write, please be aware of current active SSH sessions that might be cut off as they might be dropped off during the restart. And it's a good moment to ensure you have KVM access to the server because you might lock yourself out.
In particular, when you do service net restart, it will take down the network interface and put it back up. What won't be there after that is your default route. If you have DHCP, it'll renegotiate or whatever. But if you had a static IP address, you also need to do service routing start in order to get your default gateway back.
Yeah, or do route at default GW. And the default
no
gateway.
GW. It's not Linux. Just route, add default, and the IP address.
Oh, right. Yeah. I keep mixing them up. Okay, but after that's done, after reconnecting, our newly created loopback device is active. So there's now LO1 with a bunch of internet addresses on it, 192.168.0.1 till .9 at the end. This is the one that we set earlier. So now, setting up. PF part of the FreeBSD base system, so we only have to configure and enable it. By this moment, you should already have a clue of which services you want to expose. If this is not the case, just fix that file later on. In their example, they have a jail running a web server and another jail running a mail server. And so there's a public IP address definition here, and so you do a little packet normalization in the PF config, as well as setting the outbound connections from within the jails. So you do NAT on EM0 from LO1 networks to any outgoing via EM0. And the web server jail is defined at 192.168.0.2. So you do a redirect on EM0 protocol TCP from any to the public IP address that we defined earlier in the file on port 443 because we communicate securely to 192.168.0.2. And this basically goes on for the rest of the file. And once you have that, now enable PF like this. Maybe check the syntax for the PF conf before you start PF. Otherwise, you might be able to not log in again because you locked yourself out. Or if it's not a proper PF config, then it won't start up. But just enable it by using sysrc pf_enable equals yes, which adds it to rc.conf. And then you start it with service PF start. And hopefully, if you have everything correct in there, your networking is still up and the jails can now communicate. So next up is installing EasyJail. So what EasyJail is a collection of scripts by Erdgeist that allows you to easily manage your jails, hence the easy in it. So you run a simple package install EasyJail, which will give you all the necessary bits to run EasyJails. And as an alternative, you could install EasyJail from the ports tree. Now we need to set up the base jail, which contains the shared base system for our jails that every other jail will pull down on or link to. And in fact, every jail that you create gets that base jail to symlink directories related to the base system, like /bin and /sbin. And this can be accomplished by running EasyJail admin install. And you do the next step by copying the resolve.conf file from our host to each new jail, because otherwise, or the new jail one, which in return will pull it into each new jail that is generated, because those jails will also need a way to resolve host names. So that's the template for newly created jails in the new jail directory. And to ensure that the domain resolution works, you copy this resolve.conf in there, and then each new jail will grab it. Last but not least, we enable EasyJail and start it with sysrc again, EasyJail_enable equals yes, and service EasyJail start. So now that EasyJail is running, we can create our first jail. To do that, you run EasyJail-admin, give it a name, in this case web server, 192.168.0.2 was chosen as the IP address for that one, and then you run EasyJail admin start web server. So that jail is now running. And you can access that right away using EasyJail admin console web server, which logs you in, even though this might not have a networking yet, because the EasyJail command console will always connect you into the jail. Each jail contains a vanilla FreeBSD installation, so right from the install files that you have used to actually install the host. And next time, or the next step is to deploy the services in the jail. Now you can spin up as many jails as you want to set up our services like a web or mail server or file shares even. You could take care not to enable SSHD within your jails, or you should actually take care not to enable that, because that would cause problems with the service's IP bindings. But this is not a problem. Just SSH to the host and enter your jail using EasyJail admin console. Yeah, this is a nice tutorial, and using PF you can basically use your one public IP address and internally route it to each individual jail.
Yep.
Pretty nice. Yeah, so thanks for that tutorial. And
the other bit of news, we can tease you with the schedule for EuroBSDcon 2018.
Yeah, excellent. That's actually something I'm looking forward to.
Yeah, the opening keynote is still a secret, but after that, we got Tom Jones is presenting hacking together a FreeBSD presentation streaming box for as little money as possible. I'm very interested in that. He has quite a bit of expertise in that area, and I very much would like us to have a bunch of little streaming boxes we can take to these conferences and live stream every conference. Mark Espy will be talking about advances in OpenBSD packages, and David Karyai and Camille Ratarski are talking about LLVM and the state of sanitizers on the BSDs. Kirk McCusick will present the evolution of FreeBSD governance. Andrew Fengler, who actually works for me, will be presenting FreeBSD, what to not monitor. And Kristaps Johnson will be presenting OpenBSD and diving. That'll be interesting. I will be presenting how my company uses ZFS boot environments at scale as a mechanism for atomically updating servers remotely. Ingo Swarzi will talk about better documentation on the web and for LibreSSL. And Avandal will talk about fast, reliable packet filtering in NetBSD using Lua scripts. That's cool. You could do really interesting firewalling with the flexibility of Lua scripts like that. Baptiste Rezon will do his introduction of FreeBSD in new environments, similar to the one at BSDcon. Karsten Strothman will talk about the end of DNS as we know it. Seven Jalian will talk about what's in store for NetBSD 9. Michael Stanek will talk about FreeBSD on the ARM Power NV. So the Power 9 hardware has a native hypervisor. So you can actually run the IBM thing or FreeBSD as the hypervisor, and then you run multiple virtual machines on the hardware. So it's kind of hardware where virtualization is kind of in the hardware a bit. But you can run FreeBSD as the bottom underneath the the hypervisor kind of thing. So we'll be talking about that. Michael Voigt will talk about from Hello World to the VFS layer, building a badmin-like tool for Dragonfly's HammerFS.
Oh, cool flag of Dragonfly.
Alistair Crooks will talk about changes, modern source code tracking and management for NetBSD. And that is just the first day.
Yep.
Then on the second day, we have a talk about NetBSD kernel bug roast to the next level, kernel sanitizers, porting S6, the startup tool, to FreeBSD as a PID 1. Bob Beck will present Pledge and Unveil on OpenBSD. Live patching the FreeBSD kernel. We've all wanted that for a decade or so. Then there's removing ROP gadgets from OpenBSD, integrating libfuzzer with the NetBSD userland, profiling packet processing, performance, and peculiarities, self-hosting an alternative to the public cloud. So if you want a cloud, but you want to do it yourself, Defora OS, NetBSD, and the future of the internet, multicast network testing, a presentation on the FreeBSD graphics stack by Nicholas Sizing, debugging lessons learned as a newbie trying to fix NetBSD, and then the FreeBSD VPC, a new kernel subsystem for cloud workloads, being a BSD user, and finally, GN as a modern make replacement.
Followed by the closing keynote.
Yes.
Oh wow, they've picked a very diverse schedule. So it's not just programming; it's also like security, porting. There's something for everyone, I guess, in there. That's well.
There's toolchain stuff. There's everything, and there are tutorials. So if you come on the Thursday and Friday before the conference on the weekend,
oh yes,
advanced container management with libIOCage, managing BSD systems with Ansible, ports and Poudriere. libTLS tutorial for TLS beginners, an introduction to the FreeBSD operating system, or an introduction to BGP for developers and sysadmins.
Oh yeah, I will be tutorials and giving one in the morning, as you saw, and doing the rest of this and the next day, doing tutorials, visiting them and see what other people have to teach me, which would be an interesting concept. So yeah, go to EuroBSDcon, register, sign up, be there. It's better live than watching the recordings. Time for the news roundup this week. We have an OpenBSD on iBook G4. They haven't been around for a while, but it's possible to run it. This is over at bobstechsite.com.
Because someone wrote in that they had hardware like this, and they were wondering if they could run BSD on it. And the answer is
perfect.
Yes.
This is the exact item for you. And many others. Maybe there's still a couple of them around on eBay or in some basement or attic, whatever. Anyway. So they've mentioned on social media and on the BTS podcast a few times that they wanted to try installing OpenBSD onto an old Snow White iBook G4. Bob here acquired last summer to see if he could make it useful as a useful machine in the year 2018. Yeah, a couple of years late, but still, it's a decent machine. So this particular eBay purchase came from 14-inch 1024 by 768 TFT screen, 1.07 gigahertz PowerPC G4 processor, 1.5 gigabytes of RAM, 100 gigabytes of HDD space, and an ATI Radeon 9200 graphics card with 32 megabytes of SD RAM. Remember, folks, we were excited back then to have this configuration.
Yeah.
But the optical drive, Ethernet port, battery, and USB slots are also fully functional. That's also important to have. And the important thing that doesn't work is the battery. But it's not unexpected for a device with that age that was originally released in 2004, so 14 years.
So it's just the BIOS clock battery, which is easy enough to replace.
Yeah, not a big deal. So the initial experiments go like this. This iBook originally arrived at his door running Apple macOS 10, Leopard, and came with the original install disk. The iLife and iWork suits for 2008. Oh God. Various instructions manuals that no one reads, a working power cable, and a spare keyboard. As you'll see in the pictures here, they look for this post. The characters on the buttons have started to wear away a little bit from 14 years of intensive use, but the replacements need very good cleaning before they decide to swap them in. So yeah, it's not too difficult, and you can see how the machine looks like, and you can still see which button has which label.
I don't know if you can hear. You can see what this is my spare keyboard that I use to try to type slightly more quietly during the show. But the keys have definitely deteriorated over time.
Whatever reason, you must be a Unix user. Control C, maybe? Control D? But yeah.
But yes, this keyboard is so old it was mostly from gaming, and Control was like crouch. But yes, Control C and V are used a lot. And Control T. But most of the wear you can see is on WASD because gaming.
Yeah, that's fine. Okay.
This is like 4 keyboards ago. I'm not sure why I still have this keyboard, but...
Nostalgia. So back to the article. After spending some time exploring the last version of OS X to support the IBM PowerPC processor architecture, they tried to see if the hardware was capable of modern computing with Linux. Something they knew ahead of trying this was what the Wi-Fi adapter was unlikely to work because it's a highly proprietary component designed by Apple to work specifically with OS X and nothing else, but they figured they could probably use a wireless USB dongle later to get around this limitation. So unfortunately, They found that no recent versions of mainstream Linux distributions would boot off this machine. Debian has dropped support for 32-bit PowerPC architectures, and the PowerPC variants of Ubuntu 16.04 long-term support, Vanilla, Mate, and Lubuntu wouldn't even boot the installer. So the only distribution they could reliably install on the hardware was Lubuntu 14.04 LTS, the previous LTS version. So unfortunately, Bob is not the biggest fan of the LXDE desktop for regular work, and a lot of ported applications were old and broken because it clearly wasn't being maintained by people that use the hardware anymore. Ubuntu 14.04 also approaching the end of its support life in early 2019, so the limited solution also has a limited shelf life. Over to BSD. So they discussed the problem with a few people on Mastodon, the social network, and it was pointed out to them that OS X is built on a Darwin kernel, which happens to be a variant of BSD. NetBSD and OpenBSD fans in particular convinced him that their community still saw the value of supporting these old machines and that he should give BSD a try. And apparently yesterday, or at least from the blog post date, they finally downloaded the Mac PowerPC version of OpenBSD 6.3 with no idea what to expect. Okay, they hoped for the best but feared the worst because the last experience with this operating system was trying out PCBSD in 2008. Oh, that's not too bad, I guess. And discovering
what 10 years ago.
Yeah, so it's Unix, CP and LS are still there and doing the same thing. And
well, their problem was that it didn't support the hardware in their Toshiba laptop. Toshiba is never that big of a brand for Unixy laptops.
Yeah, and they discovered with disappointment that it didn't support any of the hardware. Yeah. So when it initially booted OpenBSD, it was a little surprised to find the login screen provided no visual feedback when he typed in his password, but can understand the security reasons for doing that. The initial desktop environment that was loaded was very basic. All you could see was a cursor, a console blinking, output window, a terminal, and a desktop switcher in the X11 environment the system had loaded. So after Googling a bit, we found a blog post that had fantastic instructions to follow for the post-installation steps. So that's linked in the show notes. You have to adjust them slightly, though, because the iBook only has 1.5 gigabytes of RAM, and not every package that page suggests is available on the Mac PowerPC port. You can see the full list also in our show notes. That's the FTP listing of OpenBSD. And the final thoughts here is that he was really impressed with the performance of OpenBSD's port for the Mac PowerPC. And it boots much faster than OS X Leopard actually on the same hardware, and unlike in Lubuntu 14.04, it doesn't randomly hang on for no reason or crash if you launch something demanding like the GIMP graphics editor. He was pleased to see that the command line tools he used to using on Linux have been ported across too, or they were originating from BSD in the first place. But OpenBSD also had no issues with them performing basic desktop tasks on XFCE, like browsing the web with NetSurf, playing audio files with VLC, and editing images with the GIMP. Limited gaming is also theoretically possible if you're willing to build them, or an emulator from source with the SDL support. And if you wanted to use the system for heavy-duty work, then you'd probably be inclined to run key applications like LibreOffice on a Raspberry Pi, then connect the iBook to those using the VNC or SSH connection with X11 forwarding. BSD is Unix after all, so using the ancient laptop as a dump terminal would work reasonably well. So in summary, they were impressed with OpenBSD and its ability to breathe new life into this old Apple Mac. He's generally excited about the idea of trying BSD with other devices on his network, such as an Asus EEPC 900 netbook and at least one of the many Raspberry Pi devices he uses. Wherever he goes, the whole hog and replace Fedora on his main production laptop, though, remains to be seen. Okay,
it mostly depends what the laptop is, whether that will work out nicely or not. If it's Lenovo, it will.
I wonder about the battery life for this one.
On the Mac, it depends how badly it's been treated and if the battery's ever been replaced. But yeah, a 2004 laptop, the battery is not going to be.
Yeah, not the best one. But yeah, for home use, that's where power connector is readily available. That's not too bad. Okay, nice story. So last week, remember, we read a blog post, and apparently that blog post was so well received that not only on Twitter, but that the author, Mariusz, our good friend here, wrote another one, the template user with PAM and login.
Yeah, so it says, when you build a new service or an application, you need your users to be able to configure it from the command line. To accomplish this, you can create system accounts for all registered users on your service and assign them a special login shell, which provides such limited functionality as just being able to configure this one service. This can be painful if you have a dynamic user database. Another challenge is authentication via remote services such as Radius. How can we implement services when we authenticate through something like Radius and log in as a different user? Furthermore, imagine a scenario where Radius decides on which accounts we have the right to access by sending additional attributes. So, to address these two problems, we can create a template user. Any of the PAM modules can set the value of the PAM user item. The value of this item will be used to determine which accounts we want to be able to log in. Only the template user must exist on the local password database, but the credential check can be omitted by the module and then authenticate with one of the users from the remote database. So this function exists in the login function, used by FreeBSD, Hardened by BSD, Dragonfly BSD, and Illumos. This functionality doesn't exist in the login used by NetBSD or OpenBSD because they don't support PAM modules. In addition, it is also noteworthy that such functionality was also in OpenSSH, but they decided to remove it and call it a security vulnerability in CVE 2015-6563. I can see how some people may have seen it that way, but that's why I recommend reading the article from the OpenPAM author and a FreeBSD security officer at the time explaining how it actually works. But knowing the background, let's take a look at an example.
Mm-hmm.
So here we have the PAM SM authenticate function. And what it's going to do is get a user, get the authentication token, and decide who can log in. So it says, in the listing above, we have an example PAM module. The PAM get user call provides the username. The PAM get auth token shows us a secret given by the user. Both functions allow us to give an optional prompt, which should be shown to the user. The authenticate function is our crafted function, which authenticates the user. In our first scenario, we wanted to keep all users in an external database. If authentication is successful, we then switch to that template user, which has a shell script set up, allowing us to configure the machine, but nothing else. In our second scenario, the authenticate function authenticates the user against Radius. Another step is to add our PAM module to the system file. So in etc pam.d/system or etc pam.d/login, we add, for authentication, this pam_template.so is sufficient, and it should allow a local login. Unfortunately, the description of these options goes beyond what they can fit in this article. There's a whole book on PAM Mastery by Michael Lucas. If you'd like to know more, you can read the PAM manual. The last thing we need to do is to add our template user to the system, which can then be done using the add user command, or simply by modifying the password file. But you can see we create a template user who runs user local bin template shell.
Okay.
As you can see, the template user can be locked, and we can use the PAM module. So you can see the password is set to star, which means there's no password you can type in that's going to hash to that. So you cannot log in locally as the user template. But when you log in as PAM or via PAM and it authenticates you against Radius, it's then going to run you as the template user. So you log in with your network, your credentials from the rest of your network, whether that's a Radius or an LDAP or whatever. But then PAM is actually kind of logging you in with those credentials as the template user, so that you don't have to have every user that exists built into your Unix system. And Marius would also like to thank Dag Erling Smargrave for pointing out this functionality to him when he was looking for it some time ago, trying to build something like this for his appliance.
Mm-hmm. Yeah, it's a great start to extend PAM because it's actually the pluggable authentication module, so you can plug stuff in that you need. And yeah, this is a nice way of showing how people can extend that.
Yeah.
Well, if you want to extend your little hardware park or just your little machines in the server room, then check out our sponsor for this week's episode, IX Systems, because they can provide you with the right, whether it's a storage system or a full-blown server, they have the right solution and can build it to you to your needs in case you have some special requirements that the off-the-shelf vendors cannot do.
It goes all the way across the spectrum, whether you need, a terabyte of storage in a little machine that's quiet that you can put under your desk at your office or your home or whatever. Or if you need something that's like, I need 1,000 terabytes of storage for my big data cluster or whatever.
That's not too unrealistic.
Yeah. It doesn't matter if you're a dentist office that just has a little bit of data, or if you're a TV production house who has all this raw video that is really, really important that we don't lose. Your data is important, so you should put it on ZFS. And if you're going to do ZFS, you want the best hardware. And the best way to get the hardware that matches with ZFS is to call the people over at IX Systems.
Yeah. And you can also not only call them up, you can also find them at trade shows. For example, VMworld, that they have visited recently. Is that still going? No, it must be over by now.
But, one of the most popular things to do with your big storage server is to use it to back a bunch of virtual machines. So it says, we're counting down to VMworld 2018 and hope to see you there. The IX Systems team will be out in full force showcasing how the TrueNAS M series and X series storage appliances combined with IX Systems servers are a perfect match for your VMware infrastructure or Zen or whatever else you're going to be using. Join over 20,000 fellow VMware users for several days of sessions, tutorials, and expo hall exploration. If you drop by the IX Systems booth, you can meet IX Systems people face-to-face and use their slot machine for your chance to win a FreeNAS Mini.
That's nice to take home with after that show. Excellent. Yeah, see, this is IX Systems generosity and showing what their systems can do.
Yep. And because the TrueNAS appliances are all VMware Ready certified, it means that it will integrate into your VMware stuff perfectly, and it is supported. It's a supported configuration by VMware.
Exactly.
So check that out. So speaking of that, we have
we're connecting segments.
A ZFS server.
Yep. And what I like about this one, it starts with the right question. What is the need? Because sometimes I see people just building stuff and don't know why, just because they do things. And this is the right question to ask for them. What is the need? And this is answered by this blog post, actually. So that goes.
It says, at work, we run a compute cluster that uses an Isilon clustered file system as the primary NAS storage. Excluding snapshots, they have about 200 terabytes of research data. Some of that is in compressed formats and other is not. We need an offsite backup file server that would constantly mirror our primary NAS and serve as a quick recovery source in case of data loss in the primary NAS. This offsite file server would be passive. It would never face the wrath of the primary cluster workload. In addition to the role as the primary backup server, this solution would also do passive report generation and workloads like that. The backup server would keep snapshots in a best effort basis dating back up to 10 years, eventually having to prune to free space. However, this data on this backup server would be archived to tape periodically because snapshots are not backups.
Important
so looking
wisdom.
at it, they would have their primary NAS going to a backup NAS and then going to tape. So why not go with enterprise NAS or just buy more Isilon boxes? We decided that enterprise-grade NASs like the NetApp FAS or EMC Isilon were prohibitively expensive and overkill for what their needs were. An open source and cheaper alternative to enterprise-grade file systems with the level of durability we needed could come from ZFS. We've already spoiled from using snapshots by the clever copy on write file system Waffle from NetApp, but ZFS provides snapshots in an almost identical way, but ZFS doesn't have a limit on the number of snapshots like NetApp does.
Yep.
I checked one of my machines recently. I have over 20,000 snapshots.
How taken every
not in one data set. So there are 500 data sets, each of which has like 45 snapshots.
Oh, taken in regular intervals?
Yeah.
Okay.
So they have snapshots every 15 minutes for a bit, and then every 2 hours, and then every 12 hours, and then every 3 days. So there's about 45 total snapshots going back a month and a half times 500 data sets.
That's a lot. Yeah, that would be the limit. Yeah, that would be the limit for some of the storage appliances you can get out there, but not ZFS.
If I'm not mistaken, the limit on a NetApp is 256 snapshots per file system. Because they have just a binary bit array of what the snapshots are or whatever. Anyway, ZFS provides snapshots, and that's why they considered it over something like CentOS with XFS. So then they were down to, should we use FreeBSD or Debian for ZFS? Since this is the backup server, a long-term solution, stability and reliability are key requirements. ZFS on Linux may be popular at this time, but it's still a lot of churn in development and crazy bugs like that data loss one. So they're not looking for cutting-edge features here, perhaps Linux later. So we already utilize FreeBSD and OpenBSD for infrastructure services and have nothing but praise for the stability of these BSDs. So, okay. ZFS, but do we do FreeBSD or FreeNAS? So they say, well, FreeNAS provides an integrated GUI management tool over FreeBSD for novice users to set up FreeBSD ZFS in jails, but the user-facing abstraction adds an extra layer of complexity to maintain, and basically they're FreeBSD enough that they don't need that. So they went with this server, a Lenovo SR630, with 2 Xeon Silver 4110s, 768 gigs of RAM, a 4-port SAS card configured in a JBOD mode, some Intel 10 gigabit network cards, 128 gigs M2 SSD as a boot drive, and 2 HDST 4U 60 drive JBODs containing a total of 120 10 terabyte SAS disks.
Cool.
Both the JBODs are connected to the rack using dual SAS cables for connectivity redundancy. The rack server would see 120 disks attached to it that it can use. The rack server was in turn connected to a switch with a high bandwidth link to the primary server. Once the physical setup was complete, it was time to install FreeBSD. A simple vanilla installation of FreeBSD 11.2 from the USB install media, and then, FreeBSD update fetch, FreeBSD update install, do a package upgrade, install Nano, HTOP, ZFS Snap, and rsync, enable SSH, and you have your file server.
Yeah, it's that simple.
And enable ZFS. That's kind of
yeah, of course, yeah. Yeah. But
so they laid out their thing in RAID Z2s of, I guess, 12 disks, 10 data plus 2 parity, and 10 separate VDEVs. So when building out a ZFS-based file system, one needs to be careful to plan the number and type of VDEVs. So how many stripes you're going to have, basically. The number of disks in each of those VDEVs, etc., according to their specific needs. Simple fact is that the more VDEVs you have, the more speed you're going to get by having more IOPS. But the wider your VDEVs are, the better storage efficiency you're going to get. It's the more space for the number of hard drives. So you kind of, wider is more efficient, narrower is faster.
And with RAID Z2s, 2 disks can die without jeopardizing the rest of the pool.
Each of the 10 separate VDEVs. But he says, given that I have 120 disks at my disposal, I needed to choose between the following options. Decided to go with RAID Z2 so that the system can tolerate the simultaneous failure of 2 drives out of each set of 12. Considering that I have some hot spares, going to RAID Z3 seemed to be overkill. So in raw storage, with 120 10 terabyte drives, that'd be 1.2 petabytes. Or, when not using marketing terabytes, that'd be 1,091 terabytes maybe. So looking at his options, he could do 9 VDEVs of 13 disks each, plus 3 spares, which would give him 900 usable terabytes. Or he could do 14 VDEVs of 8 disks each with 8 spares, but that would lead to only 763 terabytes of usable space. Or we could do 11 VDEVs of 10 disks each, and 4 spares, which would give him 80% efficiency for 800 terabytes. And then 1 additional VDEV with only 6 disks to add another 36 terabytes. That one's a little weird. I guess it couldn't quite go to 12. And so he decided to do 14 VDEVs and 4 spares, giving him 836 terabytes of usable space.
Okay. Yeah, it's good to have that comparison of effectiveness versus speed versus redundancy.
Mm-hmm.
Okay, you can see the glorious zpool status output that kind of goes over a couple of screens. Yeah, trimmed here for brevity.
Yep.
But now the curious case of missing 65 terabytes comes up, which is interesting, because if you have that amount of storage, 65 terabytes is a lot missing. So where did that go?
I think that works out to what?
Yeah, so they write
8.5% or so.
Mm-hmm. So according to the table they listed earlier, he was supposed to have 800 terabytes of usable ZFS storage, but sees only 735. Where'd the 65 terabytes go?
Yeah, so part of it is that ZFS has to leave room for its metadata, right? When you write 1 megabyte of data in ZFS, it takes more than a megabyte of storage to hoard that, because we need the block, then you need the indirect blocks that point to it. So if you're writing a megabyte of data, you actually, by default, write that as 8 chunks of 128K. So then you need a block that points to those 8 chunks, and then the block that points to that. And the metadata we store 2 copies of, and the top level metadata we store 3 copies of. And so there's all this overhead.
Yeah, and that's what they figured out by saying, or figuring this out by using that Reddit post and the calculator there. So if you take reservations for parity and padding into account and add an extra 2.3% of a slop space allocation, it explains the missing 65 terabyte storage capacity.
Yep.
Storage...
But if you use large blocks, if you enable the record size of 1 megabyte, you can usually save 6 or 7% back by storing 8 times less metadata for each 1 megabyte of data, and a bunch of things like that that can help. Plus, yes, if you get some compression, then suddenly you're going to fit a lot more data in a lot less space. Even if you only get like 1.1 to 1 compression, that 10% gain over 700 terabytes of data is more than the 65 terabytes of overhead you lost to ZFS.
So yeah. That's cool. Now, of course, starts the discussion about compression and deduplication. And the conclusion there is, of course, having chosen LZ4 compression, we decided that the cost of dedupe in terms of memory requirements is not worth the effort in our use case and many other use cases like that. So there's that.
And they talk about enabling ZFSD to automatically enable those hot spares if a disk fails, setting up ZFS snapshots, and so on. How to recover a file from a ZFS snapshot. And sysadmin is happy when you restore that deleted file. How to make recursive snapshots, how to configure the automatic snapshots, etc., etc.
Hey, it's a very detailed blog post, about really setting up ZFS for a big server. And
they also look at tuning the scrub and resilver delays, since on the case of the backup server, they're not worried about the live load. And so they want the resilver and scrub to happen as quickly as possible, not to try to not disrupt the live load. And so they've set the scrub delay down to 0 so that it will not try to moderate the number of IOPS it spends doing the scrubber resolvers.
Yeah, I wonder how long that takes still with that.
It depends a
on the
lot
data.
on how
much data is it?
how fragmented the data is, how big your data blocks are, and so on. I've got really good speeds off resolvers recently on my video storage servers, but those are, tens and tens of terabytes of 1 megabyte blocks, all big files that have never been modified. So they're all linear and they read and write really quickly.
Mm.
But they also walk through a bunch of other stuff in here. It's worth checking out.
Yeah, because they write that performance-wise, they will write another blog post soon after they push the system a little bit. So that's exciting, and we'll see how to get that in a future episode.
Yep. So next story.
Oh yeah, reflections on a 1-year usage of OpenBSD. So this is a nice user story that we found about using OpenBSD for a year. So Nanxiao's blog, I guess that's the name, yeah. They've used OpenBSD for 1 year, actually, and it is time to give a summary of the experience. What do I get from OpenBSD? That's the first question. A good Unix tutorial. When I'm curious about some Unix commands implementation, I will refer to OpenBSD source code, and I actually gain something every time. Like, for example, the refresh socket programming skills from Netcat. They know how to process files efficiently from cat. So then there's B, a better test bed. Although my work focus on developing programs on Linux, I will try to compile and run applications on OpenBSD if it is possible. And one reason is that OpenBSD usually gives more helpful warnings, like this one. Warning, sprintf is often misused. Please use snprintf. And other secure programming advice like this. So don't just let the warnings scroll by, heed them, and you will find you have a better program. Or you can refer to another post that this author wrote, which is more about secure programming and programs crashing on Linux, other than an OpenBSD where they are stable, or where at least OpenBSD can help you find the hidden bugs. C is that some handy tools are available in OpenBSD. For example, TCP Bench is useful for porting it to Linux for his own server projects. There's another link here for that if people are interested. And what did the author give back to OpenBSD? That's also great. So first, patches. Although most of them are trivial, not modifications, they're still my contributions. Yeah, see, small things like that make a big difference.
That's how you get started.
And everyone basically benefits from that. Everyone who uses OpenBSD can get this. And next is write a blog post to share experiences about OpenBSD, like this one. Yeah, thanks for that, so we can cover it in the show. C mentions they develop programs for OpenBSD like LSCPU and Free. So that's also great to have. And they're linked on the GitHub page. And porting programs into OpenBSD, for example, Google Benchmark is a nifty tool but lacks OpenBSD support. So he submitted a PR and it was accepted. So you can use Google/Benchmark on OpenBSD now. Excellent. So generally speaking, the time investment on OpenBSD is rewarding. And if you're still hesitating, why not give it a shot? Yeah, so see, small things like that, small blog posts make it into the show. And they're great user experience stories because the experiences are different, and of course use cases are different, but most of the time they're happy with the BSDs, whatever BSD it might be, and in this case OpenBSD because of their secure programming. So, time for BSD Bits this week. We have another reminder for the BSD Users Stockholm meetup that we already announced last week, but it's never enough to mention it while it's still fresh. And again, this is happening on September 5th at 5:30 till roughly 10 p.m.
Yep.
And it's in Kungsbron, Stockholm, very close to the train station, so it's easy to reach. And if you're in the area, we have already 20 people attending that one, but there could be more.
Yes. So hopefully we get a report on how that meeting went.
Oh yeah, excellent.
Yes,
yeah,
and for all the people who've been nagging Dan repeatedly and constantly since BSDcon, I finished posting all the videos from BSDcon 2018.
Woo!
every one of the talks is posted. Sadly, there were 2 people who forgot to turn their microphone on.
Oops.
The one was kind of interesting because they turned it on at the end, thinking they were turning it off. And so you can hear them answering questions from the audience.
And saying goodbye. But that's all.
But all the videos are online. The slides are very high quality video because it was captured directly from the projector. And it's the audio is from the Lavelle lav mic. So it's all quite nice.
Yeah, so thanks for making those available.
Yes, thanks for Dan for organizing the conference, Celine for editing the video, and University of Ottawa for having the equipment to record all the video for us. And I did the posting. So yes, all 45 videos are up for you to watch. Each one is approximately an hour long. So have fun with that.
Relive the conference in your living room. Yeah, at least the talking parts. Okay, we have infos from OpenSense 18.7 because that's been released recently. They have a little forum post here. Dear friends and followers, for 3.5 years now, OpenSense is driving innovation through modularization and hardening the open source firewall with simple and reliable firmware upgrades, multi-language support, hardened BSD security, fast adoption of upstream software updates, as well as clear and stable 2-clause BSD licensing. And what's the prominent changes since version 18.1? That's a long list.
Yeah, go check it out if you're interested. But they have improved DHB v6, more v6, and more v6, and more v6, improved default gateway handling and gateway switching, TOTP support for extra authentication, and ZFS root boot support, although the installer doesn't actually support it yet.
Okay. That's a work in progress. But yeah, it's a nice update for your OpenSense firewall. And yeah, check it out.
Yep. Then we have a video here. Somebody tried out TrueOS 18.3 on their ThinkPad T410. So this is a 10-minute video review of TrueOS. So check that out.
And there's a kernel hacker wanted. We have a little post here from Chris Moore, my predecessor on this show, remember?
Yes,
he's
Chris
still
used
around.
To host the show here. But IX Systems is looking for a kernel hacker to join their OS team. They're fine with international or remotes, but the skills they're looking for are experience working on ZFS, iSCSI, NFS, networking, the disk subsystems in FreeBSD, including Geom, and just performance in general. If you're interested, send your resume over to chris@ixsystems.com, and they'll have a conversation.
Yeah, this is your chance to work more closely with kernels or the FreeBSD kernel actually, and in the storage space.
Yeah.
Next,
then we have a selection of interesting commits recently.
Oh yeah, we like them, so we put them in the show. The first one is replace a pair of 8-bit writes to VGA memory with a single 16-bit write, because this is the work that Colin Percival has been doing to speed up booting.
Yeah, so in VGA text mode, the buffer has a pair of bytes for each character. So the first byte is for the actual character, what symbol you want to put in there, and the second one has attributes about it, which include the foreground and background colors, and so on. So when updating the screen, we're writing these 2 bytes separately. So you write the character, and then you make it red. You write a character, and you make the background green, or whatever. In some virtualized systems, every write results in the glyph being redrawn into the graphical virtual screen. Writing these 2 bytes separately results in twice as many updates to the screen as is needed. Whereas if we perform a single 16-bit write, writing the 2 bytes at once, the character only needs to be redrawn once. So in the case of an EC2 C5.4x large instance, which I think has like 192 CPUs or something like that, it cuts the time to boot into the kernel by 1.3 seconds, speeding it up to 7.6 seconds from 8.9 seconds.
Okay, yeah, slowly we're chipping away from the boot time. And especially in these huge instance machines, that makes a difference.
Yeah. Well, it's just, it only makes such a big difference on that machine because it's printing so many lines because of the number of devices.
CPU 1, 2, 3, and yeah.
Then we have a commit from upstream ZFS. Matt Ahrens originally wrote this, I think. Yeah. Reduce task queue and context switching cost for the ZIO pipeline. So ZFS has this thing called the ZIO pipeline where your data comes in at the top or the bottom, depending if it's a read or a write, and goes through a bunch of transformations before it hits the disk. And this is where checksumming happens, where compression happens, all those type of things. So it also has the child-parent relationships. So like, don't update this block until this block is written to the disk because that block is going to stick its checksum into this block and so on. So when doing a read from disk, ZFS creates 3 ZIOs. A null ZIO to be the parent, a logical ZIO to handle the work, and then the physical ZIO that's actually going to pull the data off the disk. Currently, each of these results in a separate task queue dispatch on the ZIO execute function. On high read IOPS workloads, this causes a significant performance impact. By processing all 3 of these ZIOs in a single task queue entry, we reduce the overhead on the task queue for the locking and the context switching. We accomplish this by modifying the ZIO done, which is the callback that gets called at the end, to instead of a void, it now returns the next ZIO to execute. So when the task queue calls, it does the work. Instead of going back to sleep and then picking up some other task queue, when it's done the work, it gets told what to do next. And it keeps working until it gets to the end of the chain, and then it goes to sleep and gets to the next task queue. This results in about a 12% performance increase for random reads, going from 96,000 IOPS to 108,000 IOPS when reading 8K records from some SSDs.
Yeah, so if you have those configurations on an SSD with a record size 8K and you have that specific revision, it's a small speed bump or increase actually.
Well, the amount of improvement might also depend a lot on how many CPU cores you have and so on, and your type of workload. So the performance boost could be even more depending on your system.
Yeah, so small changes like that add up in the end.
Yes, and as good as we keep doing more and more work to try to get ZFS to get more performance out of it. Next up, we have a minor change proposed by Mark Johnson for, well, it's actually for the FreeBSD VM system. It will have an impact on ZFS. So he says, before the rework of the page daemon control loop, we compute the inactive queue scan target, so how much memory we need to free, after running the low memory handler, which generally will free a bunch of pages because it does things like shrink the arc. Now we run the PID controller before running the low memory handlers. So we may potentially overshoot the target. So we look, oh, there's not very much free memory, so we run the PID controller. But when we're figuring out how much memory we need to free, we haven't done the easy work yet first. So then it ends up causing the arc to be shrunk, possibly, sorry, it can cause things to be swapped out too soon. So even though there's a bunch of memory in the arc that could be given up, or even memory the arc has given up but is still in the cache in the kernel memory allocator. So there's all that free memory just sitting there, and we give it up if we were asked, but because we're low on memory and we haven't done that yet, the PID controller would cause processes to be swapped out, even though there was lots of free memory. So this change runs the low memory handler first, in order so that when we tell the PID controller, hey, you need to go find some RAM for me, it doesn't end up returning a lot more RAM than we needed, causing performance to go down. So this also fixes a related problem. Currently, the low mem handlers are only ever executed by the domain 0 page daemon. This means that low mem handlers only ever get executed in response to a shortage of free pages in domain 0. If you have a multi-socket system, there's other domains, and you might not, just because you're out of memory in one of those, it won't necessarily trigger this correctly. So allow any page daemon thread to execute the low memory handler and use an atomic to ensure that only one attempt is made per low memory period. So to do this, I switch back to using ticks instead of uptime, and it's a time t, and the platform-dependent width of this type makes it difficult to use atomics. So there's a very small patch, but hopefully this will lead to less swapping under load with ZFS by asking ZFS to give up its memory before declaring that we're critically out of memory and need to start swapping.
Mm-hmm. Yep, that's excellent to have, but there's still a bit more review required for that one, but I guess it will eventually land.
Yes, and so one of the other VM experts has made a proposal for a possibly even better way of doing this.
See, that's why you do reviews, actually, to get more input. Speaking of input, did you recently change your files and maybe need to back them up? Then it's better to do this properly with, for example, Tarsnap, which sponsors our feedback and questions section this week and the many weeks before that. Check out Tarsnap, the online backups for the truly paranoid. You want to make backups, but you want to make them in a secure way if you store them in the cloud, and that's what backups with Tarsnap do for you. They will create and segment your deduplication data, then figure out which blocks are unique in there, then compress those, and then encode them locally before it sends them up into the cloud, so no one can read it there.
Yeah, if you're the type of person that cringes when you hear backup to the cloud, this is the right service for you because it makes sure, in a way that you can verify yourself, that your data is encrypted with a key only you have before it goes into the cloud. So all the cloud gets is a bunch of gibberish that they can't possibly read. And then you can decrypt it later with the key if you want, or if you want the data in the cloud to never, ever, ever be read, all you do is destroy the key, make a new one, and do your new backup with that new key, and no one will be able to read your old data.
Yep, and if you can use tar, then Tarsnap is easy to learn, and there are also a couple of versions available for the most popular systems out there, the Linuxes, the BSDs, Mac OS X, and Windows subsystem for Linux, so there's no excuse of not doing a backup on whatever system you are on.
Yep, it's pay as you go. Just put some money in. You'll never get a surprise bill this way because you pay and then use up the money, and then when you put in more money, and it only takes $5 to get started. So why have you not already been doing this?
Yep. So time for feedback and questions that we've been receiving, and keep sending it. If you are curious about something, wonder about BSDs, if we can help somehow, whether it's ZFS or any other Unix question or about BSDs in general, in particular, that is our feedback and questions part. Send this to feedback@bsdnow.tv and we'll cover it in a future episode. First question we got for this episode is Anian, starting with a little longer message, but goes like this. I still love the show. I follow most Jupiter Broadcasting podcasts, but TechSnap is probably my favorite, the old and the new format. Okay, fine. I have a question about backups. I managed to cause some major problems at my own company when I fiddled with our Nextcloud's encryption settings, and accidentally crypto-locked a lot of our data. Ooh, dear. I started on one evening when a colleague of mine had problems syncing some files. So he had a look at the logs, and it seemed that had something to do with the server-side encryption he turned on a few months ago. Since it was causing problems, he decided, tired after a long day at work, to just turn the encryption off again. After checking the manual, created a snapshot of the volume the data was stored on and entered the commands, and went home. The next morning, everybody turned on their laptop, and a lot of files started syncing, but they could not open them. They were suddenly encrypted. Oops. It turned out that there is a bug with the decryption, so there's a GitHub issue there. And add insult to injury, the file snapshot alone did not help recovering immediately because he had forgotten to snapshot the database as well. Oh dear, which was on another volume. I'm still trying to recover some data. Luckily, a lot of data was not synced yet or could be recovered otherwise, but I'm still working on it. Oh dear, that's a bad situation to be in. But that's just the backstory. Now to his actual question. Where can I find resource to build a better backup solution for our company? In general, snapshots are great, but I get the feeling that they are not a useful backup for data, and they definitely don't fit every need I have. So I want to back up a file level.
Snapshots are not a backup, and in this case, you have a snapshot of the encrypted data and the key was somewhere else and you don't have a snapshot of the key. It was your problem.
Game over, man. Yeah. We covered this in the show earlier. Snapshots are not real backups. Not the only solution for backups. Don't just rely on snapshots.
For some reason, I swear that we might have read this feedback previously. But anyway.
No, it's new, at least for me. So they want to back up on a file level. With being a listener, since Dan was a host, I, of course, looked at Bacula, but I'm not sure how complicated that is to manage. An alternative might be Burp, but in general, I'm not sure where to start. Do I need such tools, or are some cron jobs with rsync fine for the start? Where can I learn more about good backup practices? The Bacula handbook is great, but are there any other go-to resources? Am I overthinking it, and I just need to make sure I have a copy of all data somewhere, no matter how organized? Are snapshots just fine? We are just a startup at that point, so it's not a huge amount of files in total. It would be great to get some input from you in this topic, and how you manage backups in cloud infrastructure, for example, at DigitalOcean. Keep going with a great show, and greetings from Germany. Oh, wow. Yeah, see?
So, so while snapshots are not a backup, it seems like he would have been perfectly fine if he had had a snapshot of the entire Nextcloud thing, rather than just the one particular data set that had the files on it. But yeah, you probably do want a real backup, and Bacula is not really designed for backups when you have just one file server that you want to back up. The number of components you end up setting up is quite a bit of work. It works out great if you have 10 or more machines that you want to back up. Then Bacula's, it amortizes the cost and it's worth it. Especially if you end up with hundreds or thousands of machines. But when you just have the one server, backups get a little more complicated. rsync is probably not the great answer there. Dave in the chat room recommends URBackup. I've never heard of that before. It also depends on how much data you're talking about. If there's just documents and not a lot of large media files, then Tarsnap's a great answer for a backup that's taken care of and doesn't cost a lot. Although it doesn't scale well. Using a backup that goes to the internet doesn't generally scale well when you're talking about terabytes of data.
Yep. Yeah, I know that you're now a little bit panicking and don't want to repeat this error again. But I know people have lost data before and they came out better after that. So thinking about these questions is good. One thing I would recommend is looking at the OSBC, the Open Source Backup Conference, which happens in Germany. It's from the same organizers where we went to for the OSDC, the Open Source Data Center Conference. And they have videos and recordings of the talks available. So if you want to do a little bit of research, what backup solutions other companies are using or recommending, you can do a little bit of research there. I think they have the slides and the videos separate, so you can just look at the slides without having to watch the whole video. But that's a great resource for people who want to learn more about backups or how other people employ backup strategies.
Yeah, so snapshots help a lot in avoiding you needing the backup, but you still want to have the backup.
Yeah, so good luck next time, and don't be scared to do backups, and test the backups by doing restores to a different system, just in case. And yeah, then you should be fine. Don't be too scary about it. It's fine. You'll get it right. Okay, that's next question is from Robert, a pool question. I guess with this hot weather around, it's not a question about the swimming pool. It's ZFS pools, of course, and that goes like this. Hey, Alan, I have been a long-time listener of Jupiter Broadcasting and have been watching since the first TechSnap episode and was hoping that you could share some of your magical ZFS knowledge and powers to help solve a problem that I have been created myself and stumbled upon. So I have a Z pool with 4 VDEVs that are mirrors of 2 drives each. Yesterday, after a reboot of my main FreeNAS server, the pool became unavailable. After several reboots and Z pool import, I found that ZFS would simply not import the pool. It was stating that one drive for 2 of the VDEVs was unavailable and would not import the pool until they were attached. Well, the drives were attached, but I found that the FreeNAS system was outputting the error on connecting GPT rejected, and in turn would not add the device to the system. At this point, I have no idea how to proceed, and I'm in question of the stability of ZFS if a pool of mirrors can be taken down by something as simple as this. The worst part of all this is that the data is in transition, and due to this, there is no current backup. And help would be greatly appreciated. So here's a little output from his zpool status or zpool
so
import.
There's some confusion here. So the reason the pool wouldn't import is not the 2 missing disks you can see there, right? You can see in mir-2, there's a disk unavailable, and in mir-4, there's 1 disk unavailable. Those are not what's stopping you from importing the pool. Your problem is there's a mir-0 where both disks are missing. And the zpool status output doesn't include it because ZFS only knows about the VDEV if at least one of the disks in the VDEV is around. So it knows there's a VDEV missing, it just doesn't know anything else about it because all the details about that VDEV are on the VDEV and it's completely missing. So the problem here is not that you lost 1 drive from mir-4 or 1 drive from mir-2, it's that you're missing both drives from mir-0. And I worked with this user offline, and I think there was actually also a mir-5. So there were a total of 6 disks missing out of the 10.
That's a bit much.
Yeah, adds up.
Yeah, oh dear.
Sorry.
A lot of data loss this time here in the feedbacks.
But we managed to solve the problem, which was caused by some multipath a multipath label being stamped on the end of the disk, which causes the disk to be 1 sector smaller. So in this case, none of the disks were actually dead, but they couldn't be found. So you have a GPT partition table where you write a copy of the partition table at the beginning and the end of the drive. The one at the beginning has the offset of the one at the end written in it, so that if the drive is bigger, like if it's a VM and you grow the disk,
it'll
so
find
that second copy. But
makes sense.
When gmultipath or any other geom class stamps its metadata at the end of the drive, that overwrote that. But more importantly, the problem was when you access the disk via geom, when you're doing multipath, it reports the disk being 1 sector smaller than it actually is to protect that last sector where it's written the metadata, right? So then the FreeBSD would read the GPT partition table, and it would say, the backup partition table is at this address, which is past the end of the disk. And FreeBSD is like, well, that's bogus, and then won't do it. But the ZFS data, in this case, is in a partition on that disk. So it's not at the very beginning of that. It's in a partition. And so we can't find it because the partition table is not being loaded, so we're not getting a device, 80a0.p2. None of the partitions are there. And so ZFS doesn't know to look randomly, 6 gigabytes into the disk to find the start of the ZFS partition.
That's why.
So in this case, it was some misconfigured multipath. We cleaned that up and the pool imported and everybody was happy.
Whew. Data saved. Oh, wow. That's difficult to diagnose. Yeah.
But the main reason I wanted to point this one out was because the user was concerned that just because 1 drive each out of 2 different mirrors was missing, that was why they couldn't import the pool. The problem was actually that they were missing an entire mirror set.
Yeah. So it's not a ZFS stability question. ZFS is working fine, and it's just
you have more disks in your pool than you thought you did, and you didn't notice you were missing an entire VDEV.
Okay, cool. That was solved earlier offline. That was excellent. Great. So next up is Lane with congratulations. Oh, wow. Here we go. Hi, folks. I just wanted to send a quick note to congratulate you on reaching your 0.x100 episode. Do the math. I've been a listener from the beginning and haven't missed an episode yet. Oh, great. That's actually wow. It's just dedication here for the episode at the show. It's too bad that you didn't start with episode 0, but we all know that common off by 1 issues are. Yeah. Anyway, thanks for all the effort and all the great episodes. Keep up the great job. Well, thank you. That's great to hear from time to time. Yeah, that keeps us going. And keep watching. We try to provide good content. And last but not least is Thomas with an L2R question. Alan is picking the right questions here. I've been wondering, Thomas writes, if you have a NAS and some NVMe devices that reach better speed than the network your NAS is connected to, not much of a stretch, would it not be worth to sacrifice all your arc for the L2 arc table. I get that the latency will be higher, but for most use, I can't see it as a bad thing since you will basically have changed super fast cache with much more very fast cache. Do L2 arc keep both MRU and MFU data? Hope you're enjoying summer, guys.
Yes, the L2 arc does keep MRU and MFU. It's a lot of extra housekeeping for ZFS to end up doing it quite that way. Ideally, you wouldn't oversize your L2 arc that much because you'd just be wasting money. You're just gonna put terabytes of SSD cache? That doesn't seem to make a lot of sense. It depends on your record size, how much you're actually gonna end up using, and so on. You'd have to look at your workload. It's different for everybody, but in general, no, because oftentimes reads are depending on each other. So to read that block that you want, you need this metadata. Well, the latency of going to the SSD to get it versus it already being in RAM means that it's going to take longer to even find where on the disk the data is to go and read it and send it to the network. And so RAM is always better in that case. So you never want to have your arc completely pushed out by L2 arc. It's a big waste to do that.
Yeah, the more the cache has, the better the speed. And
so and really you have to wonder to yourself about how much you really want to have.
Yeah, it's optimizing in the wrong direction, I guess.
Or in particular, this sounds like a premature optimization. If your network is that slow, get a faster network.
There's always a bottleneck in the system somewhere, but the question is whether you hit that bottleneck often, or is it just so far with the current technology or the current use of the system that it's not going to be an issue for a while, so you can rest on that. And he wrote that he knows it's a stretch, but it's starting to appear more and more as people get these devices, and they think about how to properly use them in the proper way and the most efficient way. But yeah, so that's our feedback that we have for this question section and this last part of the episode. And again, send us everything that you found about the BSD so we can cover it in a future episode. And everything that you find should be sent to feedback@bsdnow.tv, and then a future episode will happen with your content.
Yes, so we look forward to seeing you next week.